Okay, so the next question that we got on the menu today is asking us, what is the principle of the superposition of waves? So the superposition of waves, let me write that out. When waves intersect, the result is that the individual components added together is what's going to be the final wave of when waves intersect. When waves intersect, the sum of the components will be equal to the resultant wave. Okay, now what does that actually, let's actually use like a visual example to see what's going on. I have a similar model here on Desmos, just a classic graphing calculator. Okay, so I'll first hide these. So suppose that we have this red sine wave, just a regular old red sine wave, and we have a blue sine wave that's like intersecting with it. So they're both going at the same time. Okay, now what the Superpositions Theorem says for a superposition of waves is that the superposition of these two waves intersecting at this point is just going to be them added together. So you can see from the green wave here, the equation is defined as exactly the red plus blue. And here, let's zoom in a little bit. We can actually close that, just get a bit more space. We can see that, okay, the value of the point here, that's green, is 1 is equal to 1.7508. We should see that this should be precisely the same as the value of the blue at this point, which is 0.909, plus the value of the red at this point. And if we do some quick math in our head, we can see that, hey, 0.8415 plus 0.9093, that has to be precisely the same as this. So that's just showing, like, at this point, the superposition theorem, what you would do, you would just find the values of the individuals, add them together, and you'll get the resultant value. Okay, now if you see here, at this point right here, you see the red is 0. So you would expect that the green and the blue are precisely the same at this point, which is 0.8415. So yeah, that's pretty cool. Pretty cool. Let's say if we moved our thing along to like here, even in the negatives, it's still the same. Maybe over here is going to be a little like that. So over here, we have like negative 0.38, pretty much negative 3.9, negative 9.8. So we should expect maybe just under negative 1.3, 1.4, negative 1.4. That looks about right for what these two values added together would be. Or negative 1.37. Okay, so even when they're negative, you just add them together. You see here is a case where we have one that's positive and one that's negative. So yeah, you just add them together, or subtract the negative one from the positive one. But that's the same as just adding them together and including the signs. So superposition of waves, wherever they intersect, the sum of the components is equal to the resultant. Okay, so yeah. The above solution is good. Is good. Might be better to show an example with a square wave as the sum of the components might be more obvious. Okay, cool. Oh man. Oh man. That was our last question. Ain't that unfortunate? Time flies when you're having fun, as the old saying goes. I always have fun doing physics. So those are all the questions that we have for today. If you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button below and ring the notification bell if you're very eager on never missing another one of our OneClass uploads. If you would be interested in submitting your own questions, check out the links in the description below. Remember to leave a like if you like the video and comment your thoughts on it. Share the video with your friends if you really like the video. And this has been Millen with OneClass. I hope to see you again soon. Take care and have fun being a physics champion. Remember, physics will never betray you. Physics is fun. Physics is freedom. Anyways, take care, all of you physics champions. Take care.